All right, for 64, we move into sequence and series. So 64, what's the first term in the sequence given by this equation? So literally, we're just going to put 1 in for n, put 1 in for n. So that'd be 3 minus 6, or -3. For 65, they want an equation for the nth term of the sequence. So first off, I need to figure out, is it arithmetic or geometric? So if it's arithmetic, if we take the second term minus the first, third term minus the second, fourth term minus the third, we'll get the same answer every time. So if we did 6 minus 3, we got 3, but when we did 12 minus 6, we didn't get the same thing. So this is not arithmetic. So then let's check to see if it's geometric. If it's geometric, we should be able to take second term divided by first, third term divided by second, fourth term divided by third, and get the same thing every time. So we did second term 6 divided by first term 3 and got 2. We did third term 12 divided by second term 6 and got 2. If we did 24 divided by 12, we'd get 2. So we do have a constant ratio. This is geometric, and our ratio is 2. So look on your formula sheet for the formula for an nth term of a geometric sequence. That is a sub n is equal to a sub 1 times r to the n minus 1. So we're going to put in our first term, 3, and we're going to put in our ratio, 2, and that is our formula. Now please notice you cannot combine the 3 times 2 and get 6 to the n minus 1, because only the 3 is being raised to that, only the 2 is being raised to that exponent, the 3 is not. For 66, they asked us to do 10 factorial over 2 factorial, 5 factorial. So 10 factorial literally means 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. 5, 4, 3, 2, 1 is 5 factorial. So we can just stop there and cancel those top and bottom. And so that takes care of this 5 factorial. And then all we have is the 2 factorial on the bottom. That's 2 times 1. So that would be 109876 over 2. And you can see in the calculator, if I multiplied that out, I got 15,120. Also, you can just let the calculator do the whole thing for you. So the place that we're finding this factorial button, there are 2 different places to find that. You can go to Alpha Window, and you can see it's option number 9 there. Or you can go to Math and use your right arrow to go over to Probability, and you'll find your factorial there as well. So type it in your calculator or work it out by hand. You can see you're going to get the same thing. Then for 67, we've got the summation from 1 to 5 of 2i. So that means start with putting 1 in for i and stop when you get to 5. So I plugged in 1 and then 2 and then 3 and then 4 and then 5. And the sigma is what tells me to add these. So once I find these 5 sums, or once I find these 5 products, then I want to go back and I want to sum them together. So that would just be 2 plus 4 plus 6 plus 8 plus 10, and that's going to give me 30. Now again, you can do the sigma on your calculator. It's in that same place, Alpha Window. It's the summation right there. So when you click that, it's going to put something that looks like this on your screen. And so you can just fill in your variable. You don't have to use whatever, like this was I just hit my X button. Any variable is fine as long as what you use here, you use the same thing in your equation. So I used X here, and again went from 1 to 5. And you can see there's that same 30 we got a second ago by hand. All right, then for 68, write an equation for the nth term of the sequence 3, 6, 9, 12. So just like we did a moment ago, we have to figure out if this is arithmetic or geometric. So first off, let's see if it's arithmetic. I'm going to do 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3. So you can see here I am getting a constant difference of 3. This is arithmetic. So look on your formula sheet for the arithmetic nth term of a sequence, and here is that formula. You also have the formula on there from Algebra 2 if you like that one better. That one's a little bit different. You use the one that our textbook uses. So we found our difference was 3, and then we need to find C. So C is just the first term minus the constant difference. The first term was 3, and again, we found the constant difference to be 3, so that means C would be 0. So that'd be 3n plus 0, or 3n for our equation. Then for 69, they ask us for the 10th partial sum. Now, the 10th partial sum literally just means the sum of the first 10 terms, And then here is the sequence that they give us. All right, so again, I'm going to figure out if it's arithmetic or geometric. So I did 16 minus 5 is 11, 27 minus 16 is 11, 38 minus 27 is 11, if you keep going with that list on your sheet there. So this is arithmetic, and I have a constant difference of 11. So if I want to find the sum of the first 10 terms, then I need to use my sum formula for an arithmetic. So here's that off of my formula sheet. We're finding the sum of the first 10 terms, so n is 10, so we'll put 10 right here. And then our first term was 5, and then this is going to be my 10th term. Now, they didn't tell me what my 10th term was, so I can use my formula for the nth term to find that. So here's that same formula we used just a moment ago. Let's put 10 in for n, put 10 in for n. Our constant difference was 11. And then c is just our first term. So the first term was 5 minus the constant difference, which was 11. So c is going to be negative 6. So negative 6 in for c. So that's going to give us 110 minus 6, or 104. That is our 10th term. So that's what's going to go right here for a sub 10. So 104 plus 5 is 109 times 5 is going to give us 545. For 70, they gave us 5, 15, 45, and they asked us to find the 10th term of this geometric sequence. So they went ahead and told us it was geometric. If they hadn't, we could have figured that out. Second term divided by first is 3. Third term divided by second is 3. So we would have found out this was geometric with a ratio of 3. And they want us to find the 10th term. So I'm going to use my formula for the nth term. Here it is right here. And I'm going to put 10 in for n. Our first term was given, it was 5. Our ratio we found to be 3. And again, n is 10. So if I throw this into my calculator, 3 to the 10 minus 1 is 3 to the 9. So 5 times 3 to the 9. You cannot say 15 to the 9. That 5 is not being raised to the exponent. So if you type this in your calculator exactly as it is, it'll do order of operations correctly for you. All right, 71. It says find the sum of the first 6 terms of the geometric sequence with a sub 1 being 2 and a sub 2 being negative 4. So again, they've told me it's geometric, but I have to find the ratio. So I'm going to do second term divided by first. So negative 4 divided by 2 gives me a ratio of negative 2. And they asked me to find the sum of the first 6. So I'm going to use my geometric sum formula. This is my first term right here. So my first term, again, was 2. And my ratio was negative 2. So in the place of r, we're going to put negative 2 top and bottom. And then remember, it's the sum of the first 6 terms. So n is equal to 6. So put 6 in for n. All right, so if I have a negative 2 to the 6th, that's going to be 64. Be careful if you throw that in your calculator that you put it in parentheses. That negative has to get raised to the 6th as well, not just the 2. So negative 2 to the 6th would be 64. 1 minus 64 would be negative 63. And then down here in the bottom, 1 minus a negative 2 would be 1 plus 2, or 3. So that would give us 2 times negative 21, or negative 42. You can throw that whole thing in your calculator, but you have to be really careful how you type it in. If you leave out a parenthesis, you're going to get the wrong answer. All right, then 72, they ask us to evaluate the summation from 0 to infinity. Now, the only way you can find a sum to infinity is if 2 things are true. 1, it's geometric, and 2, the absolute value of its ratio is less than 1. So let's check that. Let's see if it has those 2 characteristics. First off, they didn't give me a list of numbers, so I need a list of numbers. So I'm going to start by plugging in 0. So I plugged in 0, and then I plugged in 1, and then I plugged in 2, and we could keep right on going. So negative 1/2 to the 0, anything to the 0 other than 0 is 1. So that's going to be 3 times 1. Then here, if we plug it in, negative 1/2 to the 1 is negative 1/2. Negative 1/2 squared is a positive 1/4 because that negative gets squared as well. So this would be 3 minus 3/2 plus 3/4. So if we go through and we do second term divided by first, third term divided by second. So right over here, second term divided by first gave me negative 1/2. Third term divided by second gave me negative 1/2. So this is geometric and my ratio is negative 1/2. Then we need to check to make sure that the absolute value of the ratio is less than 1. So the absolute value of negative 1/2 is a positive 1/2. That is less than 1. So yes, it is geometric. Absolute value of the ratio is less than 1. We will be able to find the sum. So let's grab our geometric, infinite geometric sum formula. So a sub 1 was 3, and our ratio was negative 1/2. So 1 minus a negative 1/2 would be 1 plus 1/2, so 1 1/2 or 3/2. So if I had 3 divided by 3/2, I'm going to keep change flip, and that's going to give me 2. And you can get your calculator to do those computations for you as well. Then for 73, they gave us another factorial problem. So we've got 8 factorial over 5 factorial, 3 factorial. So if you want to throw that into your calculator, remember the way we did that. The factorial button is in alpha window number 9. Or you can go to math and arrow over to the right to probability, and you can find your factorial there as well. So you can just put it in your calculator and get your answer. Or what I did here was 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. So those would drop each other out. We also had 3 factorial in the bottom, so that's 3 times 2 times 1. So that left me with 8, 7, 6 in the top, 3, 2, 1 in the bottom, and you can see when I multiplied that, I got that same 56 that we did using the factorial button on our calculator. All right, then for 74. How many different 4-digit student ID numbers can Savannah Christian create if the first digit cannot be 0? Okay, if the first digit can't be 0, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 possibilities for that one. There are no restrictions on the other 3 numbers, so we have all 10 possibilities for those. So we're using fundamental counting principle here, where we're going to go through and use our cute little blanks like we've done, and then we're just going to multiply each of those possibilities that we get. So 9 times 10 times 10 times 10 gave us 9,000. For 75, it says Drew is preparing a course schedule for his first semester in college. He must select one of 2 math courses. Okay, so out of math, he's got 2 things to choose from. One of 3 science courses. So for science, he's got 3 to choose from. And one of 5 social science courses. So we've got 5 of those to choose from. So again, fundamental counting principle. If the first thing can be done in this many ways, second thing can be done in this many ways, third thing can be done in this many ways, I multiply them. So 2 times 3 times 5 gives me 30 different possibilities. 76, 16 girls are running for homecoming queen. A queen, a first runner-up, and a second runner-up will be chosen. How many different outcomes are possible? Does the order matter here or not? Absolutely, because if you're first, you're the queen, and if you're second or third, you're not, right? So order is definitely important. This is a permutation then. So we have 16 to choose from, and we're choosing 3. The other way that you could do this is you could just use the little blanks again. 16 girls could come in first, and after one of them comes first, there's 15 that could come in second, and then there's 14 that could come in third. And again, that NPR and that NCR button, you can get to them by doing alpha window, or you can go to math and right arrow over to probability, and you'll see them there as well. All right, for 78, we have a distinguishable permutation with repeated elements. We have the word calculator, and so normally we would just say there are 10 letters in calculator, so that's going to be 10 factorial, but we have to divide out those repeated elements. So because we had 2 C's, we've got 2 factorial, 2 A's, 2 factorial, and 2 L's, 2 factorial. 2 factorial is just 2 times 1, so that just gives us 2 times 2 times 2, so there's our 10 factorial over our 8. Then for 79, it says 1 card is drawn from a standard deck of 52 cards. What's the probability of drawing a club or a 5? So that is the probability of a club plus the probability of 5 minus the probability of a club and a 5 at the same time. So there are 13 clubs in the deck of 52, and there are 4 5s in the deck of 52. But the problem is we counted the 5 of clubs here and here, so the formula will subtract that back out for us to get rid of that duplicate. So that's going to give us 17 minus 1, or 16 over 52, and we're going to put that in lowest form. Then 80 says 2 cards are drawn without replacement. Find the probability the first card is black and the second is a diamond. So that's first black times probability second diamond given first is black. So there are 26 out of 52 black cards in the deck. The probability the second is a diamond, given there's a black card still laying on my desk without replacement, there's only 51 cards left to choose from, and all 13 of those diamonds are still available because they're red. I multiply and get 13 over 1